Hello everyone and welcome back to another Universe Sandbox video. So today we're going to be turning Earth into a star, because I thought it's probably the most boring one to do out of all the planets, to be honest, because I'm pretty sure that everyone on YouTube has done it. But like I said in previous videos, I still want to do every single main object on this menu here. So yeah, I want to get Earth out the way because it's probably, in my opinion, going to be the most boring one we're going to do, because it's probably the most done one. But today we're going to be making Earth bigger than the Sun. So I'm hoping to make it about the size, maybe a little larger than Alpha Centauri A here. Yeah, this one here. I want to make, because Alpha Centauri A has got the mass of 1.1 suns, and it's a little brighter, got a little more mass in it. So yeah, so hopefully I'm going to make that Earth as large as that. And we're going to see what effects it will have on the solar system here. So I've got my custom system loaded up with my Planet 9 and Sedna additions. So let's hope this goes well. So let's go all the way to Earth and start the usual process. And it's going to be interesting to see what happens to the moon as well. So let's slow down time a bit. Turn the sound down a bit so you can hear me better. I don't know if you can hear me low or hear me right now. But anyways, so we're probably going to start. Let's start with a Venus, yeah. So obviously we're going to do it properly. We're not just going to change its stats up to a star, because that's kind of boring. We might see a bit of collisions as well. So let's put a Venus into the Earth, and that looks so sweet already. Look at that explosion. That's so nice. Love playing this game. It's so satisfying. But there we go. Oh no, my area in the world's already kind of dried up. So yeah, I live in the UK if you didn't know. But anyways, and where's the moon at? And where's the moon? Oh, there it is. You can just see it. There it is. I don't know if you just saw it there. But anyways, let's continue making Earth a lot larger. As long as we keep on throwing Venuses and stuff into it, it'll continue to get bigger. So if we just continue to spam other Earths into it, it'll continue to get bigger, bigger and bigger until we get a large enough object to make a gas giant and then eventually a star. So, whoa, look at all those explosions. Oh my god. How is Earth still got water on it right now? Okay, no, that's eventually going to evaporate. Oh my god. Yeah, look how black and dull it all is here now. Whoa, is that Africa? Whoa, look at Africa. I'm clearly dead. I don't know. Is that the UK there? I don't even know. Alright. Hang on, the UK will be up here somewhere, actually. Alright, anyways. Let's throw a few Marses in as well. Mercury's. Let's throw all the planets. Make sure we've got all of the planets in here. Let's put some Venuses. Right, how large do we need to be to eat a Planet 9? Alright. Yeah, we're nowhere near getting a Planet 9 in yet. Well, look how small Earth is compared to the original Earth. Or look how big it is compared to the original Earth. Okay, we've got a bit of lag for some reason. I don't know why that is. Why is it lagging? Okay, I have no idea why it's lagging right now. Please? Okay, I don't know why it's doing that. I'll see you once I've got the problem fixed. God damn, it's never done this before. Right, see you in a sec. Alright, so I'm back. Hopefully that does not happen again. But here we are with the Earth. It's got the same diameter. I don't know about the mass. I literally had to restart the whole game. But I looked at how large it was before I closed the game. So yeah, that's how large we were at. So let's basically continue our evolution into a star. So let's do this. Yeah, look how small it is. Oh, look how large it is compared to the original Earth already. That's pretty sweet. Right, let's see if we can throw any Kepler planets into it. Get that extra mass in. Let's try 22b. Oh, we can't even put that in yet. About these lower ones. Yeah, we can put these smaller guys in. And also got some comments saying turn Kepler planets into a star. But honestly, because we don't know much about their solar systems yet, we don't know how many planets there are. We don't even know like the diameter we don't know the exact diameter. We don't know the star. We don't know everything about the systems. We don't know enough about them. So right now I'm not planning to turn any Kepler planets into stars, because honestly I don't know. It won't be much of a difference to just turning anything into a star, because the solar systems, I don't even know if they're in the game, some of the Kepler ones. I know there are some Kepler ones, but there's obviously not all of them here. I don't know if these planets down here you're looking at now, Kepler 10b, 62e, 62f, 69c. I know 22b's in the game, but yeah, I don't actually know if they are, or if I can really do much to it, because am I even making any sense here? I'm awful, I'm sorry, but anyways, there'd be no point doing it, because there's no it wouldn't have an effect. There's only a few planets in these systems, so it wouldn't really make a big difference. It would just form a binary orbit with the star, the local parent star, and then they would just make a binary orbit and completely they would completely just start a binary orbit and maybe eject any other planets out, and that'd be it. The video would be so short, there'd be no point doing it. And what the heck happened to our Earth? I have no clue, but we're just going to delete this. Open the new simulation and pretend that didn't happen. God, I'm so bad at doing these. Alright, let's go back to where we were. So it was 11285, I believe. So obviously I must have destroyed the Earth because I made the Kepler planets too large. Alright, let's add the moon in again. There we go. Right, where's the moon? Is the moon on? Alright, let's hit play. Let's do this. Earth is frozen, but we'll fix that. No problem. Alright, let's throw some more Earths in. We're going way too fast here. There we go, that's better. And now let's just completely throw more and more Earths in, and let's terrorize what's left of the normal Earth. Just look at all of like the what do you even call it? All of those like shockwaves just going over. That's crazy. Put a Venus is in there as well, Mars is, and some Mercury. So okay. Right. How large do we need to be? Okay, Planet 9 is still a little too large. Alright. Let's continue throwing Earths in actually. Wait, can I put any? Oh yeah, I can put. Let's actually put 69 C's in. Kepler 69 C's. Yeah, I hope I didn't annoy any of you guys with my crappy, I guess like crappy explanation of why I'm not going to do any Kepler planets. Because honestly, like, we don't know enough about their solar systems. We don't even know if we've discovered all the planets in their systems. Like, there's only going to be a few planets. Like, I'll show you an example at the end of the video. Like, there's hardly any planets, so making one of the planets a star wouldn't really do much. It'd just make a binary system, then like end off, I guess. Like, that's it. Like, it wouldn't do anything. So just continue traveling in the binary system forever. Nothing would happen, pretty much. Whoa, I don't want to put a Jupiter down. That's not a good idea. What, Uranus? I guess just continue throwing these in. I don't know what I'm doing. Yeah, I've had a very busy day. Quite a tiring day. I'm not thinking straight. I'm sorry. Yeah, I suck. Okay. And I'm not funny. Yeah. Okay. All right. Yeah, I actually had someone say that. Like when I said in last episode, when I said, oh, I laughed at because I thought apparently it wasn't the same person, but 3 people commented in a very like close time period. Like usually there's hours between when people comment on my videos, but yeah, this 3 accounts commented in like half an hour, all saying to do Sedna. So I was assuming that was the same person, but apparently I wasn't. And apparently me saying it was funny, or it got someone triggered or something. I don't know. Yeah, if you check the comments on the previous video, they're like, you're not funny and stuff. I'm like, I don't really care. Think what you want to think. If you don't enjoy my videos, you don't have to watch them. You can just click away. Like, I'm not forcing you to stay here. I'm not going to be some mean guy. I'm just doing my thing and you can do your thing. Anyways, enough of that negative stuff, I guess. Let's continue. Wait, what? Wait, how did that happen? Okay, no, I didn't see that. Nothing was bigger than that Earth there. Okay, that made no sense. I'm calling that a bug. So let's go up to about this size, because like we should have been up here by now. So there we go. Look how large our Earth is. Let's make sure the moon's still in orbit as well. Let's quickly press the auto orbiter button there. Alright. Wait, it is in orbit of Earth, right? Alright, cool. Wait, what? Oh, Earth's orbit's a little dangerous. It's going to head straight for the sun now. That isn't good. Alright, yeah, but look at all the just debris here. In fact, we probably should be around this temperature right now, honestly. Alright. So, now we can throw some bigger objects in. So let's throw Uranus, a few of them, a few Neptunes in. Wait, why does that keep happening? That makes no sense. Okay, we've definitely encountered a bug here, so it looks like I'm gonna have to do it the easy way. So let's go to the massive 1 sun and let's pull it up to 1 point like that, and then let's press this, and there we go, boom. So we got our I did say I was going to make it as large or larger than the sun. It's about the size of Alpha Centauri A, like I said originally. So yeah, where is it? Here it is. And it looks like Alpha Centauri A would actually fit inside. Wait, let's just pull it out here. I just want to see how big it is compared to Earth. So let's put it 40 light years away. Right, so Alpha Centauri A is 85 or yeah 850 million or 850,000 kilometers, but the Earth is 851. Wait, is it a little small? Wait, 851 compared to, I didn't even read that last second number. 851, so 853. And our Alpha Centauri A is a little bigger, but yeah, we'll leave it at that. So we've got our Earth. Why is Earth so bright? Oh, it's the sun as well. Well, it seems a lot brighter when you zoom out than the sun. That's weird. It looks a lot bigger, even though it's not really that much bigger. But anyways, oh, I spat on my screen there. Whoops. Alright. So it looks like the moon is now pretty much going to get incinerated by this, because look how bright it is on this side. Look. Look at the day-night cycle on the moon now. That's pretty crazy. Yeah, so I have no idea where that glitch happened. Sorry about that, guys. I should probably cut it out, but yeah, I don't really have the time today. I'm quite a lazy guy, but Oh my god, the moon is gonna get shredded apart. It could get destroyed by a roosh limit, honestly, I don't know. Maybe it won't. Looks like it's just gonna get incinerated by heat, but anyways. Right, so now we've got our Earth as a star. So, let's go to the orbits, not trails, orbits. And as you can see, the inner solar system is already marked up. So let's put it in a binary orbit with the sun. There we go. So now the sun and Earth will orbit each other. It looks like Mars is going to be on a close call with Earth right now. Mars will warm up though. Look how bright it is here, because it's not just one star anymore. Now we've got 2 stars giving it daylight, so it's going to be a lot brighter. Right, let's land on Mars quickly. Let's add the pink skies. I don't know if you saw that video where I gave the planets custom skies, but yeah, let's do it. Might as well bring that feature back. So space blue, then we want to go to the pink color, because Mars is obviously a pink planet, or it has a pink sky. So there we go. This is probably what the sky on Mars would look like. So let's remove the orbits and the labels. So let's see our sunrise and sunset on the red planet, even though it's pretty much pink. Right, so is that Earth? Oh, Earth and the sun are there, I think. But yeah, both stars are in the same spot. So you can see the moon's dust trail. Look at, it's like the sun literally looks like a comet in the sky now because of the moon getting shredded apart. Oh no, there is the sun as well. I didn't even notice that. So we've got 2 suns. Hey, it's like Tatooine from Star Wars. Right, there we go. So let's see that. And sunset. So there we go. Right, let's go out of that and let's put it back on the regular Milky Way since we're not on the surface of Mars anymore. So there we go. Now, yeah, that dust trail there. Look at that. It's just all of the material getting shredded off the moon right now. Oh my god. Look how hot it is here. Still increasing as well. Hang on, how bright is this thing? Okay, it's 1.82 the luminosity of the sun, so it's pretty much almost 2 times as bright as the sun. So that's going to be pretty crazy. Let's see how the outer planets are doing. Looks like the outer planets are pretty much still the same. Oh, look at the orbit of Eris here. That orbit is definitely unstable. You can see the white one there. Whose orbit is that? And where are Sedna and Planet 9 gone? Oh, here they are. They're not even on orbit anymore. Huh, that isn't good. So Sedna and Planet 9 have pretty much already been ejected, which isn't good. Alright, let's go back to the orbits. Right, if the moon's going to cause too much lag, I may just remove it, because it'll probably get destroyed anyway eventually. To be honest, I don't know how it's surviving right now. Alright, how's Mercury and Venus doing? Oh, Venus is getting hotter, actually. Venus isn't usually that hot. Yeah, Venus is usually about just below 500, but it's at 518 degrees right now. It is decreasing, but when it gets closer to Earth, it's going to warm up. Because Earth's brighter, and if it's about the same distance away from the sun, like, the Earth will have the brightest effect on it. Oh, has Venus been ejected? Oh wow, this inner system is crazy. Wait, did we just lose Mars? We may have just lost Mars. Okay, we've lost Mars. Poor old Mars. Didn't stand a chance. Whoa, what's this here? Is this meant to be Mars? Oh, it's just a thing. It's just a, whatever you call it. What do you call it? A fragment, I guess, but it's not called fragment. Alright, well, I've got all these dust particles here. I don't know if you can see them. There's all... Yeah, I don't know if you can see there's all dust particles. But anyway, let's just remove those. So, there we go. Alright, let's go back to orbits and let's see what more mayhem we can rack up with Earth as a star. So, whoa, look how unstable the system is. Yeah, Earth is actually the closest planet to the sun we've done so far in this series. So, I can't wait to do a Mercury. I really want to do Mercury. So yeah, and also, guys, tell me what should we do next? Because I want to know. I didn't really listen to the comments, so I wanted to get Earth out the way. So we still have Mercury, Venus, Mars, Saturn, Uranus, Neptune, Pluto, Eris, Haumea, 2007 OR10, Orcus, all these ones here. We've already done Ceres as well, and I don't know what that is. That isn't one. And yeah, I really want to do Planet 9 and Mercury the most. But yeah, tell me which ones I should do. So yeah, don't pick Ceres, Sedna, Jupiter, or Earth because we've already done them. So anyways, let's get back to this. And I think it looks like the closer, or which object is closer to the star, the quicker the solar system gets completely destroyed. Well, look at this. That looks like a little something inappropriate, but yeah, I won't say it. I want to keep the. Don't want to be a little I don't want to be too inappropriate. So there we go. All right. Whoa, look how bright it is. Jeez. Is it? Oh, it's hotter than the sun as well. Yeah, the sun's 5,500, and then this one is 5,000 or 6,400. It's almost 1,000 degrees hotter than the sun is. So that's pretty crazy. Hang on, that's a white star actually. That's not even a yellow star, because the sun's a yellow star, but this is a white star. So I'll say it's a I think it's an E-type main sequence star. I don't know for sure, because I know the sun's a G-type, and if this is a white one, it's the next class up, I believe. So I think this would be an E-type star. Anyways, I don't know. Someone correct me in that if I'm wrong. But anyways, just look at the solar system right now. Like, it can't even stabilize. Like, the solar system is completely out of shape right now. Let's go on to trails. Just look at this. Like, everything is in the wrong place. Alright, let's speed up time a lot more. Wait, what's that? Wait, is that a gas giant there? Alright, okay, Saturn's been ejected. Oh, everything's getting thrown out. Mercury's gone. Is that Venus there? Oh, no, that's Jupiter. Looks like Eris is getting pulled inwards right now. Let's visit there. Let's go in. How bright is it here? Well, it's a lot brighter than normal here, so it must be quite hot. Well, it's hotter than usual, I think. It's getting colder again because it's getting thrown away. Alright. I want to say, wait, is the moon still alive? Wait, let's check the moon. Oh, it is! The moon is still there. Wow. Still in the original orbit. Don't think the moon's orbit changed much. Oh my god. Whoa, whoa, that's making my eyes go weird. Whoa, that's pretty crazy. But honestly, right, in realistic terms, I don't think the moon would have survived. It has lost a lot of mass. And radius as well. Because this is the size the moon should be. So it has lost a lot of material. Wait, let's check. Okay, that's a lot of mass there. Look at all that mass. What about moons a second? Wait, Earth's a, what am I clicking on? Kilograms a second. I think that means kilograms a second. So that's a lot. Whoa, whoa, whoa! Look at this as well. It has lost 97% of its original mass. So yeah, poor old moon is. Oh, it's only iron as well. So basically, all that's left of the moon is its core. Like all of the silicate has been like just really like thrown off it, like all blown away. That's all this trail here. That's probably all the silicate that got blown off, because if you saw there, the moon is only made out of iron now, and iron is usually the element which is deepest. Wait, does the moon even have iron? I don't know. Actually, I don't know that. I think it must do, surely. Yeah, someone correct me on that if I'm wrong. I don't know everything. Alright. So the poor moon is just... Yeah, the moon's probably getting... Look at all the smoke trail it's making. In fact, just to stop lag, the moon will eventually get destroyed anyway. So let's just remove the moon. So I don't want this massive lag trail here. Because all these particles never have their own physics and stuff. It looks like a galaxy. Look at that. You see that? Look. It looks like it's a spiral galaxy there. You can see the... Where's it? Spiral galaxy? Well, I don't even know my galaxies. I'm sorry. Alright, yeah, you can see there. It's all going inwards. That's pretty cool. Alright, let's remove that trail though. Alright. Maybe you can make your own custom galaxies with that. That's pretty sweet. Alright. So those two stars are now in a binary orbit. As you can see, they're just orbiting each other. So let's see all of the remaining objects here. What are they up to? So it looks like... I think the solar system is pretty much over now. Wait, hang on. Are these ones still... Oh no, these look like they're still in orbit. Oh no, they're not. Okay. It looks like when I click on orbits, they disappear. But you can clearly see that it looks like Uranus, Jupiter, and Charilico, I can never pronounce that one. Looks like they're still in orbit, and maybe Sedna as well. How far away is Sedna from the suns right now? Let's have a look. Right, orbit. Okay, so it's 144 astronomical units. So yeah, so everything out of this area here is really far away. How far away is Uranus? Let's have a look. 20 astronomical, 19-ish. So that's probably the orbit of how far Neptune usually is. But all of these objects are pretty much just in pitch darkness, right? Pitch black, like. There's no way they're getting any daylight anytime soon. So yeah, you can just see here, go to Sedna, complete darkness. What's the furthest object away from the main stars right now? Let's have a look. Oh, it's got to be this one over here. It's got to be Saturn or Mercury there. So Mercury is probably now an ice planet. So let's add a little bit of ice on it. There we go, water, there we go. Mercury's now an ice planet. Ice dwarf, I don't know. Alright. Let's go back to Venus. How's Venus? Where is Venus? Oh yeah, Venus is out here now. So, how hot is Venus? Venus is minus 215, not the hottest planet anymore now, are we? So its atmosphere probably would have disappeared, so it'd be like that, honestly. Alright. So how hot are these ones here? So, these are still pretty far away. Like, the original Earth would probably be 1 AU away. So the original Earth would be pretty much about there, if we were going to add it in. So yeah, the new Earth is a lot closer than the old Earth was. Or the Sun Earth. Oh wait, that's the Earth there, isn't it? Yeah, I can tell. You can see there's a little... If you just look there, like if I remove the lines, you can see that that one looks a little more white than this one does, because that's obviously how it goes. But anyways... Oh, that's pretty cool. But anyways, I think that will end off this episode, because it seems like not much else is going to happen here, honestly. So yeah, make sure you tell me which one I should do next. Like I've already said, I've already told you which ones to pick from, but... Yeah, interesting. Alright, so looks like whichever, like the closer the object we turn to the a star is, so looks like the closer we are to the sun, when we turn that object into a star, it seems to cause more havoc a lot quicker. Because remember how long Jupiter and Sedna took to interrupt the solar system's orbits? Well, the Earth did it pretty much instantly. Like we saw Mars's orbit was completely changed as soon as I hit the play button, pretty much. So, looks like when we do Venus and Mercury eventually, they're going to cause even more havoc than the other planets will. Or maybe not. Who knows? I haven't actually tried it out. But anyways, hopefully you all enjoy this video. And yeah, if you don't enjoy it, then click away, I guess. It's your choice. But anyways, yeah, that'll do it for this video. So if you liked it, make sure you leave a like, subscribe, and yeah, please tell me any tips that I need to do to improve my commentary. Like, how can I improve? Like, I know I'm not the best. I know... like, even I can work out myself. I may act like an idiot when I'm doing these, but yeah, I like doing it. I'm sorry, but anyways, yeah. So tell me anything I need to improve. Yeah, literally just tell me. So, and hopefully maybe I'll reply to you. I don't know. I haven't really been replying to comments lately because there haven't really been many, and I didn't really think the need to actually reply to them. So yeah, there you go. I guess I'm not trying to be rude here, but yeah, I guess that's it. So. Hopefully you all enjoyed, like I said, and I'll see you in the next video. Goodbye. Properly, we're not just going to make, like, change its stats up to a star, because that's kind of boring. We like to see a bit of collisions as well. So, let's put a Venus into the Earth, and that looks so sweet already. Look at that explosion, that's so nice. Love playing this game, it's so satisfying, but there we go. Oh no, my area in the world's already kind of dried up. So yeah, I live in the UK if you didn't know. But anyways, and where's the moon at? And where's the moon? Oh, there it is. You can just see it. There it is. I don't know if you just saw it there. But anyways, let's continue making Earth a lot larger. As long as we keep on throwing Venuses and stuff into it, it'll continue to get bigger. So if we just continue to spam other Earths into it, it'll continue to get bigger, bigger, and bigger until we get a large enough object to make a gas giant and then eventually a star. So, whoa, look at all those explosions. Oh my god. How is Earth still, like, got water on it right now? Okay, no, that's eventually going to evaporate. Oh my god. Yeah, look how black and dull it all is here now. Whoa, is that Africa? Whoa, look at Africa. I'm clearly dead. I don't know. Is that the UK there? I don't even know. Alright. Hang on, the UK will be up here somewhere, actually. Alright, anyways. Let's throw a few Marses in as well. Mercury's. Let's throw all the planets. Make sure we've got all of the planets in here. Let's put some Venuses. Right, how large do we need to be to eat a planet 9? Alright. Yeah, we're nowhere near getting a planet 9 in yet. Well, look how small Earth is compared to the original Earth. Or look how big it is compared to the original Earth. Okay, we've got a bit of lag for some reason. I don't know why. Yeah, this one here. I want to make, because Alpha Centauri A's got the mass of 1.1 suns, and it's a little brighter, got a little more mass in it. So yeah. So hopefully I'm going to make the Earth as large as that, and we're going to see what effects it will have on the solar system here. So I've got my custom system loaded up with my Planet 9 and Sedna additions. So let's hope this goes well. So let's go all the way to Earth and start the usual process. So, and it's going to be interesting to see what happens to the moon as well. So let's slow down time a bit, turn the sound down a bit so you can hear me better. I don't know if you can hear me low, or hear me right now, but anyways. So we're probably going to start. Let's start with a Venus, yeah. So you'll see we're going to do it. That is why is it lagging? Okay, I have no idea why it's lagging right now. Please. Okay, I don't know why it's doing that. I'll see you once I've got the problem fixed. God damn, it's never done this before. Right, see you in a sec. Alright, so I'm back. Hopefully that does not happen again. But here we are with the Earth. It's got the same diameter. I don't know about the mass. I literally had to restart the whole game. But I looked at how large it was before I closed the game. So yeah, that's how large we were at. So let's basically continue our evolution into a star. So let's do this. Yeah, look how small it is. Oh, look how large it is compared to the original Earth already. That's pretty sweet. Right, let's see if we can throw any Kepler planets into it. Get that extra mass in. Let's try 22. Hello everyone, and welcome back to another Universe Sandbox video. So today, we're going to be turning Earth into a star, because I thought it's probably the most boring one to do out of all the planets, to be honest, because I'm pretty sure that everyone on YouTube has done it. But like I said in previous videos, I still want to do every single main object on this menu here. So yeah, I want to get Earth out the way, because it's probably, in my opinion, going to be the most boring one we're going to do, because it's probably the most done one. But today we're going to be making Earth bigger than the Sun. So I'm hoping to make it about the size, maybe a little larger than Alpha Centauri A here.